So as it said in that previous slide, I'm going to be talking about updated TCG TPM 2.0 specs. Let me just say, the reason I do these talks generally is because not many of you folks are active involved in TCG. I was talking to Gary Simpson a little while ago, and pretty much he and I are the only ones here that are active in the TCG PC client group. There's companies like Microsoft and 2 or 3 of the OEMs that are fairly active, but those representatives are not here, and they may or may not be communicating to you folks what you might care about. So I wanted to make sure that we do that. So that's why I've been talking about this several times. The last several Plugfests, I've been kind of beating this drum. Back at the Summerfest at Microsoft in 2013, TPM 2.0 chips had pretty much gone through the sampling stage and were starting to volume ship at that point. And I talked a lot about how do you talk to the chip at the low level. You know, how can you interact with the chip at that point? Because that's really the only thing that was out there. There was no PC client or spec at all about how to use this thing and what to do with it and what was different about TPM 1.2 between that and 2.0. So there really wasn't a whole lot to say except, gee, here's the low-level stuff you have to do in order to talk to it differently. Then in the Plugfest last March, I did a fairly extensive review of the differences. This was in Taipei, yeah. What was difference between 1.2 and 2.0 and the newly published at that point PC client specification. We'll talk about that more in just a moment. And I also mentioned in that there were a few things in flux. And a few things that after that spec was published, people said, oh, gee, we forgot this or didn't deal with that properly or whatever. And so what this presentation is today is some specs that are just about to be released and the material that's in them and how that's been updated since the one that was published last March. As it says here, it's not yet published and it's out for public review in the next few weeks. It was supposed to be out before today's presentation because we're really not supposed to talk about working group product. Just like our working groups here, we're really not supposed to talk about stuff externally until they're published and visible to the outside world. It didn't quite make it. We had a few little problems along the way, and then it was out for a vote to release it just this week, and several of us, Microsoft was nice enough to do a line-by-line review and found about 3 bugs per page, I think, of this 1,000-page document. And I went through it preparing for this presentation, and I found 13 or 14 references to a section of the document that doesn't exist anymore. So we pulled it back again, and we're going to be working on getting it out in the near future for public review. It won't be officially published. The public review should be sometime in October, I expect. And they do a 60-day IP and public review where everybody can see it, including you folks. So expect that. And then after 60 days, if there are no screaming problems with it, then it becomes officially published. But you'll be able to see it in just 2 or 3 weeks. But I do have official dispensation from the workgroup chair to talk to you folks about this, even though it's not officially published. So even though you're not TCG members, many of you, I have permission to expose this. The specifications you probably care about at this level for people who are doing UEFI-related code. And that includes IBVs, anybody who's doing firmware-related stuff, OS vendors, IHVs that doing option ROMs, a lot of the people that are here, essentially. The specs you care about is the PC client platform firmware profile specification, and the published version is 0.21. The one we just reviewed and didn't publish was 0.40, so progress has been made. Hopefully we'll get that new one out in October. And something for those who have read TCG specs in the past, particularly the 1.2 ones, there used to be a spec that was similarly named, but it was all entirely conventional or what we call legacy BIOS related. And then there was an EFI platform specification that was essentially a differences document that said, if you're doing this UEFI thing that's totally new, wasn't new at that time, but if you're doing the EFI thing, here's how you have to follow everything that's in the conventional BIOS spec except these things. That was messy and awful. So when TPM 2.0 came out and we needed to do a fairly major rework to the spec anyway, we decided that UEFI is it. And we can totally ignore the conventional or legacy BIOS. So the spec was entirely rewritten top to bottom and only talks about UEFI firmware. So, yay, we won. TCG doesn't even consider conventional BIOS worth talking about. So it's not in the spec at all. Then EFI, the TCG group, has a handful of their own protocols that are specific to TCG, and they write their own EFI protocol specification. And I'm going to, when I go back, there's some links at the bottom here where you can find specifications in public review and a resource directory where all the published specs are. I went hunting around in the published specs one for the EFI protocol specification, and I can't find it. It's there, it's published, but I could not find it for the life of me, so I'm going to carry that back. So if you're looking for it in the next couple of days, give it a little time. It's out there somewhere. But, and then last, the physical presence interface specification that focuses specifically on physical presence, as was fairly obvious. So these are the three specs you care about. That old split between conventional BIOS and UEFI BIOS is no longer an issue. Just that one at the top, and the latest version of that is what you care about. As I said back in March, most of the stuff that's come out in that PC client spec, the platform firmware profile specification, which is the PC client spec, isn't in EDK2 yet. There's some pieces of it have drifted in, but the vast majority of it is not there yet in the code base, in the open source code base. So that work needs to be done, including these updates that I'm going to be talking about today. They're even newer and they're not even published yet, so clearly they have largely not appeared in the code base. We need this to happen, so we need open source folks who are interested in working on this stuff, who have an interest in TCG. Maybe if the TCG folks that are not here in this forum that care about it may want to cross-pollinate a little bit and work on this a little. Talk to your company folks about this. It could really help to get this stuff in. Also, I'm not going to talk about what Microsoft presented yesterday about the TREE, or Trusted Execution Environment Protocol, in the EFI spec. That's outside the scope of what I'm talking about today, but it is that protocol. Microsoft, as they said in their presentation yesterday, essentially did it on their own and then submitted to TCG, and it became part of the protocol specification. So that's in that EFI protocol spec that I said you can't find. Okay, here's the changes. As I said in my March presentation, in the 0.21 version of the spec out there, they had entirely removed the event log from the ACPI tables. What was thought was the protocol, there was an EFI protocol supplied by TCG that gave you the address of the event log in memory. And it was thought that would be perfectly adequate. Microsoft at the time was happy with that, and that did everything they needed it to do. In the conventional BIOS days, there used to be a pointer in the ACPI tables that pointed to the event log in memory. So you could get to it either via ACPI or the protocol. But it was thought, we don't need that anymore. So they took it out of the ACPI tables in the first version of the spec. It's back. It was discovered the Linux guys really wanted to access it via the ACPI tables. They didn't want to use the protocol in general. I'm hand wave, lots of Linux people out there with different distros and different approaches. But some of the Linux guys said, we really would like to access it via the ACPI table. And there was a fundamental problem that cropped up. OSs during the boot process, do some actions that they would like to be able to add to the end of the event log, but the protocol very specifically says the address of the event log is only valid until you call exit boot services. And upon exit boot services, the memory that contained the event log was potentially reclaimable, and the event log wouldn't be there anymore. So if you use the protocol to get the address of the event log and then called exit boot services, the event log potentially was no longer there and you couldn't access it. This presented a problem because OSs want to log events that occur right around exit boot services essentially after exit boot services has been called, and now they don't have access to it anymore. The ACPI table gives them that access. And it also says very specifically that the event log must be 64 KB minimum in length. It can be bigger, and if you're routinely making event logs that you're having to truncate because you don't have enough memory in them, you probably want to make it bigger. And that also clearly can't be reclaimable memory because it has to be present after exit boot services. So what people end up doing in this world, what we did in the conventional biostasis, is we had one copy of the event log sitting in memory someplace and marked it whatever status we thought was appropriate, in this case non-reclaimable, and had both pointers, whether it came from the protocol or it came from the ACPI, pointed to the same hunk of memory. But theoretically, you could make two copies of the event log and put it in two different places and then reclaim the one that had exit boot services, but that's implementation dependent. So as it says, the OS may add to the event log at runtime. Typically, this only occurs right around the exit boot services time, and then the event log stays static from then on, but after exit boot services. And on several of these slides, I put a note at the bottom saying, here's the section. That is in the .40 version of the spec. Theoretically, something could change and they might be off by a little bit and all that, but hopefully they will stay exactly the same. So if you're looking for the section where this material is, chances are real good that it'll be right there, but just be aware that still editing the spec. Tagged events. These are basically custom events that you can put in the event log that are unique to your platform, your circumstance, your special device, whatever. In the event, most of the event log entries are very specifically prescribed, exactly what they are, what goes in them, their length, et cetera, et cetera, et cetera, and they're generated pretty automatically. But it turns out for purposes of attestation and a few other odds and ends, it was really useful to create your own event log entries and just add them to the event log. And again, this is another situation where they were deprecated and essentially removed, and then people said, whoa, wait a minute, we have a use for that, we want to put it back. So, as it says here, the special tagged event type is prescribed, and the structure of the header essentially is prescribed, but then the content is whatever you want it to be, totally flexible. And again, section number where you can look that up if you care. This is an interesting one that relates to some of the things we've been talking about here. Secure boot related variables are normally measured into PCR7. Many of the measurement details about how and what and when and under what circumstances and explanations and all that have changed massively. So you really want to read section 2.3.4. If you're writing code that relates to this, how measuring the secure boot related variables in particular, and support for 2.5, and really there's really not a change, so it applies to 2.6 as well, really, of the UEFI spec. They added support for deployed mode and audit mode. There's all kinds of things that say, if you are using 2.5 of the UEFI spec and you support deployed mode and audit mode variables, here's where you measure them, how you measure them, the circumstances and all that. So that's all been added to the spec. One interesting thing that generated a lot of discussion and argument is, what do you do if during the boot process, for whatever reason, you decide to change the value in one of those variables for the next food or whatever the circumstances are? You already measured them. Now, due to some circumstance, you decide to change their value during the boot process. What happens then? And after lengthy ad nauseum discussion in the TCG working group, what they decided was the default in most cases was to, Gary is commenting that a lot of things that most things that happen in the TCG working group are that kind of discussion. Anyway, the typical case in most all cases, if you change one of those variables, you should just go ahead and reset the box right now and go back and start over again your boot process with the variable in the new state. That's probably the most typical case. But if there's a circumstance that you can come up with where you just want to leave the variable in its new state and continue the boot, you are required to remeasure those variables into PCR1, not PCR7. So just FYI, that's a new gotcha in there that you have to read carefully and make sure you're paying attention to. And again, section 234. A lot of work was done on clarifying and understanding and put informational code in there, as Vincent was talking about. A lot of informational code was added to explain what it's meant by when the TPM is disabled or hidden, what you should do about it, how the system deals with it, what happens in those states. And for those who may say, well, why in the heck would you want to do this? In general, hand wave, there's a lot of detail behind this, but in general, if the TPM is disabled, it's some user, as people were commenting on. I think Andrew said yesterday that a lot of people think that TPMs and secure boot and all that are evil stuff from the devil, and so they want to do everything they can to disable TPM, so they go into their BIOS settings right away and disable TPMs and things like that right away. So this is sort of the end user saying, I don't want my TPM to be used, I think it's evil. That's the disabled case. The hidden case is the other situation where an OEM wants to entirely make it appear that there is no TPM on this box. And this is frequently for shipment into countries where TPMs are illegal, like China and other places like that, where the government has ruled that you cannot sell a box with a TPM on it in that country. They've relented to the point where an OEM can have a special SKU that essentially removes the TPM from the ACPI table, so it appears that it's not there, and there's no way to tell it's there, and there's nothing to do with it. It's physically soldered to the board, but it's not accessible in any way. So there's a lot of issues and explanatory text about how to handle that in the PC client spec. That's been updated and added to in this latest version for clarification purposes. And Section 8 and sprinkling of places all over the spec talk about this. A great deal of the event log information has been updated and additional explanatory text been added. Basically, the problem is, as Gary was commenting earlier, these discussions go on, and the people in the room at the PC client specification become experts on the gory details of all this stuff. But when you hand this huge spec to an implementer and say, here, write the code, make that happen, they all go, I don't. Even with the explanatory text, they kind of, I don't understand what this is supposed to do, why it's doing it. This is a pain. I don't understand it at all. So, based on feedback from specific implementations from a couple of companies, they said, my developer didn't understand this at all. We need to add some text to this section and that section and all. So we took that feedback and added both normative detail where that was appropriate and a lot more informative text to help people who were actually trying to implement this thing. There were a bunch of air-conditioned definitions that were very unclear. So what happens when the TPM returns errors under this circumstance at this point in the flow, and you get an error from the hardware? How do you deal with that? Where do you go from here? Oh my God, I'm stuck. I can't do what I wanted to do. The TPM just is rejecting it. How do I handle that? So a lot of definitions and details were added to that. And on a spec this large, with as much detail, with as much rework from ripping out all the conventional BIOS stuff and merging in the UEFI BIOS stuff and creating an entire new document, there was thousands of typos. That it just errors and typos and stuff, and many, many more have been fixed. And then went through a lot of the explanations, generally the non-normative or informative text that Vincent was showing in his earlier slide with the little gray box that says, this is what this means and how to do it, that are embedded in there. I went through and cleaned up and reworded and made them make more sense in a lot of these cases. So it's quite useful. So I don't have specific pointers here to those. They're just everywhere all through the spec. IBVs, OEMs, and OSVs really need to make themselves aware of this stuff and include it. It really is important. You can't just ignore it. And IHVs in particular, those with option ROMs, they're going to have to read up on this a little bit and see what might affect them. We need to get all this stuff into the open source world. I'm pitching here to more people, more developers, more people that are interested in working on this stuff. And TPM 2.0 is mandatory on most platforms now. Microsoft has made it a requirement. You can't stick with the 1.2 stuff, so you need to update yourself on this new 2.0 specifications, especially since finally they're all out there. So read up. I don't know if you could hear that, but Vincent asked if there's been any discussion of putting the TCG model into the open source world and that kind of thing, essentially. And no, not really. I don't think it has been discussed at all. I don't recall hearing that discussion at all. There has been some limited discussions of maybe forming a relationship with UEFI and TCG so we could actually work together on stuff and sign a cooperative agreement between the groups so that members of both organizations could actually communicate about some of this stuff, which I think would be a good thing. But there's not been a lot of pressure to make that happen at this point. That's a really good question. What he's asking is TPMs are frequently used as a repository, safe repository for things like keys and stuff, both all kinds of proprietary uses, and BitLocker uses it to store its keys and that kind of thing. But these measurements that we're doing, the measured boot process, does anybody care? Is anybody using it? I know that the NIST 800-155 essentially implies that you need something like this to measure the boot process and then send the measurements in the event log to an attestation agent that will look at the previous or stored golden measurements against what just happened when you just booted. And you could potentially disable network access control and put a machine that booted improperly into a private remediation network and repair it, maybe reflash its BIOS or whatever and get it back into a bootable, clean bootable shape, and then allow it to reboot and join the main network, that kind of thing. That works great in the enterprise world, and I do know that there's been a lot of interest in making that happen, and I keep getting queries from customers and others saying, so do you support this? We want to make sure that it's supported by your platform because we're thinking about doing this. So there's some interest, at least at the enterprise level, and I was talking to some of the folks here in the back of the room about, gee, wouldn't it be nice if there was a open version of the same kind of thing where you could send measured boot information to a remote cloud server and get information and back to the mom and pop home user saying your system, maybe passed secure boot, but it had USB stick problem or some configuration had changed, the measurements had changed, and was this intentional? They could get messages back and deal with it from a cloud service that you could sign up for to monitor, to try and prevent rootkits and things like that. Maybe more benign ones that wouldn't necessarily fail secure boot, but still might put your system in a state you're not comfortable with. So for those watching this on tape, the comments back and forth was that might be a really useful thing, and we were talking about some other miscommunications that you don't care about on the tape.